exponential functions. Here we're going to work more with identifying those different types of functions. Are we working with a linear function or are we working with the exponential function? So let's jump right into it. Blank functions have a common, well, let's start filling this in here. 36. So we have two different functions now. Linear functions. Recall from day one. Linear functions have a common difference. Okay, it's a common difference with a constant rate of change. Okay, so write these down. Common difference with a constant rate of change. In other words, the common difference is either adding or subtracting in the table of values. And the constant rate of change is we are either going up or down by the same amount every time. So if I go up by $2 from x1 to x2, I'm going up by $2 from x2 to x3. Exponential functions. Exponential functions have a common ratio. Recall from day one, this is all day one stuff. They have a common ratio with a different rate of change. In other words, they go up differently from x1 to x2 to x3 to x4. It's not constant like linear functions. So let's take a look at number one. After graduation, you are offered two jobs. Cedar Grove Associates offers to start you at $30,000 with a 6% increase every year. Okay, that's a big thing here that we're going to learn with exponential functions. With a 6% increase every year. Maple Grove Associates offered to start you at $40,000 with a $1,200 raise per year. There's that keyword again, per year. Okay. Compare the two jobs offered by completing the table below and then answer the following questions. So, year one at Cedar Grove, starting us off at $30,000. So Maple Grove is here. Cedar Grove is the first one, which I will highlight in purple. Here's Cedar Grove. And it's saying that we start at $30,000 with a 6% increase every year. 6% increase every year. Okay, so let's think about this. What is a 6% increase each year? You should think about it. $30,000, a 6% increase on that is going to give me some number. And then the number after that, a 6% increase with that number probably won't be the same as the number I just got. So let's write this down right above the table here. Percents imply multiplication. And if it's multiplication, you better well believe that is exponential functions. If I'm multiplying to get to my next number, that is absolutely exponential functions. So there are two ways I can go about getting to year two from $30,000. The first way, which I will put here. The first way, I could multiply by, what is 6% as a decimal? That's 0.06. I could multiply by 0.06 and add to balance, aka the balance would be 30,000. Or the second way, which is the quicker way, I could multiply by 1.06. Okay? And if you can understand number two, you are going to be way ahead of the game relative to exponential functions, because if it's a 6% increase, it's 6% over what you're typically getting, right? So everything starts at 1. Kind of like the flippable, where growth has to be greater than 1 and decay has to be less than 1. Well, if we're growing 6% each year, that's a 6% add-on to 1. So multiplying by 1.06 will just give me the answer right away. And this is the way I'm going to be going about finding year 2, year 3, year 4. This is how I'm going to fill in my table. I'm going to do multiplying by 1.06. So this is where you should have your calculators. And if I am multiplying 30,000 by 1.06, 30,000 times 1.06 in the calculator, I will get back 31,800. Okay, so that's year 2. Now I want to find year 3. Again, it's a 6% increase each year. So again, I'm multiplying by 1.06. And that would come out to 33,708. Okay, year 4. Again, same thing. And then we just keep multiplying by 1.06 because that is the percent increase. So year 4 would give me 35,730. And I'll fill in the rest of the table. You get the gist now. We're multiplying by 1.06 each time. 7, 4. Okay, so just keep filling in this table until it's all the way filled in. Okay, almost done here. You know what, let's just stop at, well, we'll keep going, I suppose. Okay, finally the last one, 63,988. So 14 years into the job, we're at $64,000. That's doubling from year 1. That's pretty incredible. 6% increase each year. We start to add up pretty quick. So this is my exponential. Now for the green, for Maple Grove, starting at 40,000 with a 1,200 raise per year. So that, hopefully you guys see, that is a constant rate of change. I'm only going up by 1,200 each year. Okay, so plus 1,200. Which would leave me at 41,200. Again, plus 1,200. Which would leave me at 42,400. So write down 1 and 2 if you didn't write that down yet. I'm going to move it now. Okay. And again, plus 1,200 here. Constant, linear, 43,600. And you guys can fill the rest of this table in. I'll put a few more. You guys can fill it in. And then all the way down at year 14, let's see what the difference was. It was 55,600. Adding 1,200 to each number before, the final number came out to $55,600. Okay? So, part A, Cedar Grove models what type of function? Well, hopefully we see it is exponential. Why is it exponential? Explain. Well, it's exponential because the same number is multiplied each time. Okay? The same number is being multiplied each time, not added. Therefore, it has a common ratio of 1.06. Common ratio of 1.06. Okay, part B. Maple Grove models what type of function? Maple Grove here, going up by a constant rate of 1,200. That is a linear function. Explain why. Because the same number is added each time. Let's put that in capital. because the same number is added each time. Therefore, it's going to have a common difference of, how much am I going up by? Well, I'm going up by 1,200 each time. Okay. Part C. If you plan on moving to a different state in 5 years, which company would be the better option for you to choose? So in 5 years, which one's going to be better? Well, let's look at year 5. Right here. At Cedar Grove, I'm making $37,874. At Maple Grove, I'm making $44,800. Which one is better? Well, obviously Maple Grove, because they would pay $44,800 versus Cedar Grove with, what is it, $37,874. That's easy. Part D. If your plans change and you don't move, which company would be the better option to choose as a long-term career? Well, let's look all the way down to year 14. That's pretty decent amount into your occupation. Year 14. At Cedar Grove, I'm making almost $64,000 compared to Maple Grove, which is making $55,000, a $9,000 difference. So definitely Cedar Grove, because they would pay $63,988 in 14 years versus Maple Grove at $55,600. So this is definitely the better option. Okay, back page, flip it over. And here I'm getting some practice with seeing linear, exponential, or neither. And actually, I want you guys to do A, B, C, D, E, and F. Do number 2 right now. Pause the video, and I'm going to write down what the answers are, and you can check your work. See if you can get all 6 of these, though. Part A would be linear, because they're adding the same amount. And again, that same amount is $825 per month. Keyword is per month. We should know per. Anytime we see per, that's going to be a linear function. Part B, it's increasing by 1.5% per year. But look, it's a percent. It might have per, but anytime we have a percent, that implies it's multiplication, and that implies exponential, because percent means multiply. Anytime we have percent, that means multiply. Okay, Tina owns 4 rabbits. She expects to double them each year. Exponential, because you are doubling. You're multiplying by 2. Part D, it's going to be linear. And the function would actually look like this. Or the way we typically write it, we always write it with the x first. So y equals 0.10x plus 1600. You can just make a linear equation right from it. We've seen this problem before. Value of John's car that depreciates 20% per year, exponential. Again, because percent implies multiply. And if you can see 20%, we're depreciating 20% each year, try and think about what that would be. What would we multiply by? We would actually multiply by 0.8. And the reason we would do that is because we always start at 1. Just like in the first example, we started at 1, but it's a 6% increase, so I add 0.06 to 1. Here it's a 20% decrease, so I subtract 0.20 from 1, and I'll get 0.8. And the height of a ball that is thrown in the air. Well, the height of a ball that's thrown in the air would look something like this. And that is actually neither. That is the last function that we will learn, which is a quadratic function. But for now, we're sticking with exponential. Number 3, see if you can answer it yourself. Pause the video and see what you get. The answer is 2. Number 4, same thing. The answer is 2. And number 5, see if you can get it. Pause the video now, and I will write down the answers. This is exponential. This is neither. Increases by 100 here, but then it's decreasing by 100 here. That's not constant. I gotta add or subtract the same amount each time. And this is linear because it's going up by 150 each time. And this was exponential because I am multiplying each one by 2. Multiplication. Alright guys, that's the end of the